See, Standard 10th Max Chapter 4 Geometry, Theoretical Geometry, Angle Bisector Theorem. See, the angle bisector theorem states that, see, in a triangle, let me mark here as A, B, C, the internal bisector of, let me take the bisector of angle A. The internal bisector of, that is a line divides angle A into two equal parts. So the AD, the internal bisector of angle A divides the opposite sides. It divides CD and BD. So the ratio divides, the ratio we take here BD and CD is equal to the ratio to the sides containing this angle. Which sides containing this angle? AB and AC. So let me write the statement. The internal bisector of an angle. First line, AD is the bisector of angle A of a triangle ABC. Divides, this is first line over, divides the opposite side. Opposite side is BC. Divides the opposite side internally in the ratio of the corresponding sides. So divides the opposite sides internally in the ratio of the corresponding sides. Which side? Containing the angle. So you have to divide the sentence. The internal bisector of a triangle divides the opposite sides in the ratio of the corresponding sides. Containing the angle. The sides are AB and AC. So first let me take what is given. Given is triangle ABC is given for you, and the bisector AD is the bisector of angle A. This is also given. AD is the taken internal bisector of angle A. It bisects means it divides equally. So let me mark both the angles as equal. So let me mark it as 1, 1. So these two angles are equal. Okay. So what you are supposed to prove? To prove divides the opposite sides. That is the ratio BD by CD. BD by CD is equal to the ratio of corresponding side. Which are corresponding side? AB and AC containing this angle. So which two sides containing the angle A, AB and AC? So BD, when you take BD first means the side next to that is AB. You have to write AB. And then CD next to that AC. I have to prove AB by AC equal to BD by CD. Next, let me do the construction. I'm going to do the construction. Draw a line through C parallel to AB. I'm going to draw a line through C parallel to AB. Parallel to AB. So this is AB here. Through C I draw a line. I draw a line parallel to AB. First construction over. Next construction, what I do, extend this AD. Extend this AD so that it meets the parallel line at E. Extend AD so that it meets the parallel line at E. Extend AD to meet the parallel line at E. So here AB is parallel to CE also. We can say that AB is parallel to CE. Okay. Now let us come to the proof. So you have to learn one by one. Draw a line through C parallel to AB. Second point is extend AD so that it meets the parallel line at E. See, CE and AB are parallel. CE and AB are parallel. So here I take this as a transversal. Here this AE as the transversal. So in that case, if two lines intersect by the transversal, alternate angles are equal. Here 1 means here also I will get 1. So alternate angles are equal. So you mention that. She mentioned that here in the proof. So 1, I am getting which angle here? This angle is A. So here half of this, not fully A. And here E. Center you write A. And here E. This is equal to 1. They are equal, angle 1. Because AB is parallel to CE. AB is parallel to CE. Alternate angles are equal. You write the reason, okay? Alternate angles are equal. Angles are equal. So when I write the center angle A, you start here, remaining angle D and B. Here D and B. D and here B. Here E I have taken, so CED. C here, ED here. So these two angles are equal. See, already this also 1. These two angles are equal. So you take the bigger triangle ACE. So in this two angles are equal. So the side opposite to them also equal. If two angles are equal means the side opposite to them also equal. So two sides are equal means this bigger triangle becomes isosceles triangle. This bigger triangle becomes isosceles triangle. Right here AC is equal to CE. AC is equal to CE. AC is equal to CE. Therefore, bigger triangle ACE is an isosceles triangle. Isosceles triangle. Because of this only it becomes an isosceles triangle. This concept is over. So you can take this as part 1. See, part 1. Just I have mentioned these two angles are equal because parallel alternate. So automatically these two sides becomes equal. So it is an isosceles triangle. Come to the next part. See, CE is parallel to AB. Here one alternate angle we are getting. Here one alternate angles are we getting. So let me mark this as 2. Mark it as 2. So right here this is B and C. So you can draw one line here. Second part. This is angle B and here angle C. This is angle 2. Again you can give the reason as CE is parallel to AB. Alternate angles are equal. Angles are equal. See, write the remaining letters here. B means you start from here. A, B, D. So here 2. A, B, D. And for this one, here C means E, C, D. So A, B, D, E, C, D. Always keep the diagram with you. So you can write easily. Okay. See, now come here. See, now we have two triangles. One is ABD, another one is DCE. See, the angles are 1 here, 1 here, 2 here, 2. So alternate angles must be equal. So what do you say about these two triangles? Corresponding angles are equal. Corresponding angles are equal. So the two triangles become similar triangle. Two triangles become similar triangle. How to name the triangle? See here 1. See here 1 means A. Here 1, here E. Right triangle. And then in this triangle we have B. Here 2 we have here C for C. The remaining letter D. D. So these two triangles are similar triangles. Similar triangles. So write here. Triangle. Write that. Triangle ABD is similar to triangle ECD by angle similarity. Angle similarity. Similarity. Okay, that's all. So very easy for you. Once you showed these similar triangles, corresponding sides are proportional. Corresponding sides are proportional. And look at the corresponding sides. What you are supposed to prove? AB. So in this triangle, I have to get AB here. AB. Where is AB here? First two letters AB. So when I take AB in this first letter, here I will get here, then the first two letter here is C. CE, first two letters. And then AB by AC, I have to get AC. Sorry, see, take the right side ratio, BD by CD. Where do you get BD in the first triangle? BD, second and third letter. BD by second and third letter is CD. Okay, that's all. See, but you have to prove AB by AC. See, just now we proved that here mark it as 1. From 1, I can take CE as AC. So, AB by AC is equal to BD by CD. That's all. Hence proved. Hence proved. See, very easy one. Just you have to understand this and write. See, just have the diagram. First part I have shown this. 1 is equal to 1. So, isosceles triangle. Then second part, angle 2, I have shown this is equal. So, similar triangle. That's all. You take the ratio and prove this. So, write and see, you can do this theorem very easily. Thank you.